Hi, welcome to Physionic, the Physionic podcast. If you're unfamiliar with who I am, my name is Nicholas Verhoeven. I'm a PhD student in molecular medicine. I have my master's in exercise physiology, and I've been a cell biology researcher for a number of years now throughout my studies. Today's topic, we're going to be discussing hunger hormones, and really we're going to be discussing three different hormones. One of them is pretty popular if you're kind of into physiology and endocrinology, known as leptin. The other two are far less known, known as melanocortin stimulating hormone, or MSH, and agouti or agouti related protein. I kind of use those interchangeably, but agouti and agouti. But ultimately, it gets abbreviated to AgRP. So we're going to be discussing how leptin affects these two other hormones, MSH and AgRP. But actually, we're also going to be comparing the difference between obese individuals and lean individuals or healthy individuals, as well as the comparison of water fasting to a basic caloric deficit, and how water fasting and a caloric deficit differentially or has a different impact on lean individuals as it does on obese individuals, as well as the hormonal levels between lean individuals and obese individuals when it comes to these three hormones. Two of them, well, I guess all three of them would be considered hunger hormones. So that's going to be our topic for this podcast. Now, let me go into a bit of the background on these hormones so you can get a bit of an understanding of the landscape of the physiology. Then I'm going to go into the study design just a little bit because this information is at least partly based off of a study. The study's name is Plasma Concentrations of Alpha MSH, which is that MSH I was talking to you about, the melanocortin stimulating hormone, AgRP and leptin in lean and obese men in their relationship to differing states of energy balance perturbation. And that's where they're talking about fasting and the caloric deficit. So based off of the information from this study, I'll be going over a little bit of the study design, then we'll go into kind of the key results, and then I will wrap this all up into a nice compact piece of information at the end for those of you that just want the conclusion and takeaways. Okay, so like I said, there are three hormones of interest in this podcast that we're going to be discussing, although there are other hormones that are related to hunger, like ghrelin and CCK, and insulin is another one, which is probably the most well-known, although it's not usually attributed to hunger, but it does have an effect, and that's something I'll be covering on Physionic. If you're interested, certainly stick around for that. But the three are leptin, MSH, and AgRP. And so how do these hormones actually interact with one another? That's probably something of great interest. Now, if you're just listening to the podcast, I have a graphic up, which is hopefully extremely helpful in terms of actually visualizing this because I've got numbers next to everything. So if you'd like to see it, just hop on over to the video cast. But otherwise, as usual, I'll be describing things throughout. So don't feel like you absolutely have to. So to start off, let's start off with leptin. Leptin is a hormone that's released from the fat tissue. Typically, as you underconsume calories and as you lose body fat, your leptin levels start to decrease. So the fat tissue releases less and less leptin. Leptin has a number of different roles in the body, but specifically towards hunger, what it does is it gets secreted from the fat tissue and goes and interacts with two types of neurons that are found in the hypothalamus of the brain. So this hormone, leptin, interacts with the brain. And it interacts with these two types of neurons that are known as POMC neurons or AgRP neurons. Guess which one secretes AgRP? Yeah, it's the AgRP neuron. The POMC neuron is the one that's responsible for the secretion of MSH. Now, when leptin interacts with POMC, it actually stimulates the release of MSH. And when leptin interacts with AgRP neurons, it actually inhibits the release of AgRP. Now, why is that? Well, what it actually does is once it binds to, let's say the POMC neurons and it releases MSH, MSH is anti-food consumption, so it inhibits food consumption. However, when AgRP is released, so when there's low leptin levels, so remember, leptin inhibits the AgRP neuron, so if there are low levels of leptin, then you have less inhibition of that neuron. Then that neuron or that brain cell will then release AgRP, will be allowed to release AgRP. And as such, that will then lead to a pro-hunger situation. So it'll diminish the drive for satiety, and it will thereby increase hunger. Through a similar mechanism, MSH actually controls the AgRP neuron as well. So when leptin binds the POMC neuron not only increases MSH for its direct inhibition of hunger, but it also inhibits the AgRP neurons themselves. So MSH can bind the AgRP neurons and downregulate AgRP release. In vice versa fashion as well, when leptin levels are low, because in the previous situation with POMC, you have high leptin levels, right? You have a lot of leptin binding POMC, therefore releasing MSH. In the vice versa scenario, you have low leptin levels, which then leads to the release of this AgRP. Now, AgRP then can have its direct effects on increasing hunger, but it can also inhibit the POMC neuron. So in either scenario, you have a double action through the amount of leptin that's bound, as well as where it's bound and which type of neuron it's bound, and then the secretion of that particular compound, the AgRP or MSH. So I'll give you a little bit more of a reminder as we go throughout, but that's basically the physiology. If you have high leptin, you tend to have high MSH, and if you have low leptin, you tend to have higher AgRP, roughly. I mean, that's really basic, but that's what we're going to go with. So again, MSH inhibits hunger, and AgRP stimulates hunger. AgRP can bind the melanocortin receptors, which is the same receptors that MSH binds to, and occupy them, therefore blocking the MSH from having its action. So in that environment, that microenvironment of these different neurons of the hypothalamus, it's very much dependent on the concentration of each hormone, of those two particular hormones. So high AgRP concentration typically is associated with lower MSH levels, and then that leads to a pro-consumption or higher hunger, or you can have higher MSH, which then typically is lower AgRP, or insensitivity to AgRP, leading MSH to then inhibit hunger. So that is, one more thing, which I found really interesting, is actually genetic obesity. So you may have heard people say that obesity is largely not a genetic condition, and while that's typically true, there are cases of genetic obesity that people have gene mutations or gene variations or whatever it might be that do lend them to be predisposed to consuming more. And one of these, actually the most common mutation in obesity related to hunger, is the melanocortin receptor, which is what MSH and AgRP bind. And there can be mutations in those receptors in the obese population. About 4% of mutations or of genetic obesity or of obesity in general is due to this mutation of this melanocortin receptor. So it's kind of interesting. I mean, at least it gives some credence to understanding. If we can understand this pathway, then we can understand some of the difficulties that come from obesity. That for some people, it's not just a bunch of poor life choices or a bunch of choices in general. That some of it can be driven by genes, something that's really hard to fight against. I mean, if you have a lower sensitivity, for example, to MSH, then that means that you're going to have greater hunger drives all the time. Now, imagine trying to fight that for the rest of your life. That's incredibly difficult. So just something I wanted to throw in there, although we're not going to be focused on that genetic aspect. It's still interesting. Okay, so let's go into a bit of the design of this study. It's pretty simple. There isn't a whole lot to it. The researchers had 4 different conditions. They had lean individuals that were asked to undergo a water fast. They had the second condition, they had lean individuals that were put on a calorie deficit. And then they had a third condition with obese individuals that were asked to fast. And then, as you can imagine, the fourth condition is obese individuals that were asked to be on a caloric deficit. Now, all of the participants lost the same relative percentage of weight. So they all were either water fasting or in a calorie deficit until they lost 5% of their body weight. And once they reached the 5% mark of lost body weight, then the researchers would then measure their hormone levels. So they measured, again, MSH, leptin, AgRP hormone levels before and after each intervention. So that's fasting or calorie deficit. Okay, so now let's look at some of these results, which are really intriguing. I'd be interested in your take if you're listening to this. If you'd like to comment a few of your thoughts, I'd love to hear what you have to say on the topic. Okay, so the first piece of data is actually just looking at baseline levels. So this is before they fasted or before they implemented a calorie deficit. The researchers were just interested, what's kind of their basal, just walking around levels of AgRP or MSH. Again, MSH is or diminishes or inhibits hunger, and AgRP increases hunger. So in a comparison between the lean individuals and the obese individuals, you see, if you're looking at the screen, but again, if you're just listening, don't worry, I'm describing it, AgRP levels are massively elevated in the obese individuals. But interestingly enough, their MSH levels are also massively increased relative to the lean individuals. So the lean individuals just overall have lower levels of these hormones, regardless if it's the pro-consumption AgRP or the anti-consumption MSH. So that's a really interesting first piece of evidence that I wanted to go over. Okay, so then the next piece of data, I believe this one is correct. Yes, I believe it is. Yes, it is. Okay, so the next piece of data is simply looking at the same exact thing, but not just baseline. They're also looking, so they've got the fast pre and VLC pre. So the calorie deficit is the VLC and the fasting is obviously fast. And pre is before they implemented either the fast or the calorie deficit. And then the post is what happened once they lost that 5% body weight, either through water fasting or the calorie deficit. And here we find some interesting results because they're again measuring AgRP. They're again measuring MSH, and they're again measuring leptin. Well, in this situation, they're showing leptin for the first time. And this is in, I believe, in the lean individuals. That's what I want to say. Yes. Yes, I believe that's right. Bear with me for a second. Yes, lean individuals. So here what we see is that pre-fasting, they had low AgRP levels. However, after water fasting, they had elevated AgRP levels, which makes sense, right? Because if you're not going to consume anything, of course, your hunger is going to increase. Then looking at leptin, which makes complete sense again, that they see from high leptin levels because they were satisfied, fulfilled, etc. Their fat levels were, they had consumed enough food, everything was fine. Then they underwent fasting for a number of days. Then their leptin levels then diminished because they lose body fat, they lose body weight. They are in a calorie deficit. the most severe calorie deficit one can be in because they're not consuming anything. And then, of course, leptin levels decrease. Now, of course, that releases the brake off of the AgRP neurons. Therefore, you get this potential release of greater AgRP levels. So that's what happened with the fasting, and the MSH did not change, which is kind of interesting in its own right. However, what's really interesting is the comparison to the calorie deficit group. So again, we're still looking at lean individuals, so people that aren't overweight. We're not talking necessarily like shredded individuals or anything, just lean, just normal weight individuals. And we find that in the calorie deficit group, there's no change in AgRP, and there's no change in MSH, and there's no change in leptin. How interesting is that? That might imply that a slower weight reduction leads to a preservation of hormonal state for a while. And I'll discuss on why that might be actually really interesting and why that might be something useful to move forward with that information in mind. Okay, so that was in the lean individuals. We only saw changes in the fasting condition. Again, the decrease in leptin and the increase in AgRP. Now, I'd like to discuss a little bit on the obese individuals. So the exact same conditions, looking at fasting and calorie deficit, looking at AgRP, MSH, and leptin. And here we see that in the fasting condition, there is a drop in leptin, but no change in AgRP and no change in MSH. And both of those are higher in concentration than in the lean individuals. So even though they experienced a reduction in leptin, that still led to no change in AgRP and no change in MSH. Now, in the calorie deficit group, there was an even greater reduction in leptin, just slightly greater reduction in leptin. And yet again, we see no effect on AgRP and no effect on MSH. So what could that mean? Well, it could mean that there's no effect on the other two hormones, because it could imply some level of dysregulation, so some leptin dysregulation, or the other hormones that they're not being produced, they're not being secreted, whatever it might be, that something else is inhibiting them from changing. It also could be that these individuals, because they're obese, are insensitive to leptin. So there may be a decrease in leptin, but the signal isn't getting through into the cell through some reason. We don't exactly know why. Another possibility is that there's a delayed effect of leptin loss. So you reduce leptin levels, then what's happening? Well, typically you would see a increase in AgRP. However, in this situation, we didn't see that. So it's possible that just the measurement time, maybe if they had waited 3 weeks instead of I believe in the fasting condition, it was like 5 days or something like that. In the calorie deficit, it was like 11 days or something like that, 12 days. So maybe if they had waited a lot longer, 2, 3, 4 weeks, they would have seen an effect eventually. It's just delayed. But the researchers ended up actually saying that they thought it was because of leptin resistance. Okay, so the big conclusions, the takeaways from here. There is a difference in the amount of each hormone that's present between the lean and obese individuals. We saw that even in the very first piece of data. Fasting leads to an increase in AgRP and reductions in leptin in lean individuals, but that was not the case when consuming a calorie deficit. And so what does that mean? I kind of alluded to it earlier, is that this could imply that if you want to reduce initial hunger, just the initial forms of hunger, then slow and steady may be winning the race. That fasting leads to a dramatic drop, a very quick drop in that 5% of body weight, and that leads to a dramatic shift in the hormonal profile, thereby decreasing leptin and spiking AgRP. However, when a person is still consuming some food and they slowly taper their weight down over double the amount of time, or a little bit over double the amount of time, that could then preserve the hormonal profile. I'd highly doubt that that would be preserved indefinitely. However, just in those first week or two, at least we have evidence that the calorie deficit seems to have an advantage in terms of maintaining the hormonal profile. So really interesting there. And that's something that we can actually take away from this and potentially implement, that if you want to, and we don't have any functional outcomes. They didn't ask them, hey, are you hungry? Or, when they measure higher AgRP, they're not asking them anything like that. So this is based off of kind of a pulling together other studies as well that have shown that AgRP is associated with greater hunger and has a direct effect on greater hunger. And I'll have a lot more content on that coming up. So be sure to stick around for that in the future. Okay, so that would mean then, if you want to mitigate some of that hunger at the beginning of your diet, at least, that's what we can specifically say. And if we assume that the high AgRP is going to lead to greater hunger, then a calorie deficit would be better than water fasting in this situation, in terms of preserving that hormonal profile. And finally, in overweight individuals, fasting and calorie deficit lead to reductions in leptin. However, there's no change in the other two hormones, implying potential leptin resistance, is what I mentioned earlier, or some sort of other dysfunction or dysregulation, or some sort of other crosstalk that's happening that they're not measuring, or there's delayed effect. Something is going on there, but the researchers were speculating that it was due to leptin resistance. Okay. Well, that's what I've got for you. Hopefully you found this informative, and I think it's really interesting. Hunger hormones are something that I'm delving a lot more into of late, and I have a ton of research that I'll be dissecting over the coming weeks and months on specifically hunger hormones and fasting and all kinds of stuff related to that. So if you're interested, definitely be sure to just stick around, subscribe, and share this content if you find it useful, and if you think other people would find it useful. I'd appreciate it. All right, with that, thanks for stopping by, and I wish you a wonderful day, and I'll hopefully have the pleasure of speaking with you in the next one. Have a good one, guys. See ya.